Alright, let's read these long questions. You will realize that this part is actually not very important. The important part is here, highlight this, at rest at t equals 2, at t equals 5, and this one, velocity of 6 when t is 8. Okay, all these are the important things that we need to look out for. And if the function vt is known to be quadratic, they ask you to find it. I mean, in fact, it's given. You need to show that this is as follows. And so let's try to understand the question. Let's say the car at rest. That means when car is at rest, your v would be 0. And there are two instances when this occur, when t equals to 2 or t equals to 5. In other words, t equals to 5, these two numbers, they are the roots of this equation. Think about it, this is a quadratic, and when t equals to 2 or t equals to 5, they are kind of like the solution to this equation. So that means we can then express vt as we can form the first factor from t equals to 2, that is t minus 2. The other factor would be t minus 5, because they are both of them are your roots, and roots you can use roots to form a linear factor like that. But there is something else you need to add. You need to add something like, say, a k, because you're not too sure what is the coefficient of t squared, and so we add a k, and we can find k by using this information here, 6 and 8. And so we have this velocity function, but we do know k. Very easy. Now when t is 8, v is 6. Right, so means v8 is 6, and this is k, and 8 minus 2, 8 minus 5. If you solve this right now, you get 6 equivalent to k. This is 6, this is 3, and so k is in fact equivalent to 1 over 3. So therefore your v is 1/3 t minus 2, t minus 5. Expand this, I'm assure you will get this. It's 1/3. Expanding this is t squared. Well, this will be negative 7t plus 10, and this will be, you will have what is required of you, t plus 10 over 3 meter per minute. Okay, is it nice? And moving on, next part B, then draw a sign diagram. Of course, we already have our critical values, so the sign diagram will be at 2 and 5, and of course we take only positive values. If you do the proper sign diagram, you should get this plus, negative, and positive, and state the time interval when the car was moving to the right. This is actually a keyword. Now when the car moving to right, that means we'll always take, right, the v velocity function as positive. So what the question is asking is that when is the time when the vt is positive. So you can see from here between 0 and 2, and when t is greater than 5. So car moving to right, and t is between 0 and 2, and also when t is greater than 5. I can't take t equals to 2, so okay. Right. Next one, to find an expression for the position of car at any time. So that means we need the displacement function. We have our vt as follow. Square and plus 10 over 3. So what they ask you to find is a displacement function, which you can get by integrating v. If you integrate this, be careful about the with your integrations. You should get t power 3 is 9 7 over 6 t square plus 10 over 3t plus c. And another piece of information is given here. If the car is 1 meter to the left of O, then observations begin. So when observation begins, it means when t is 0, the car, or rather S0, is 1 meter to the left. And we know that when we talk about left, this means there's a negative. That's the reference point O. Here we saw positive displacement. Here will be a negative displacement. So it's -1 here. The car is here. So that means when S0 given this, okay, so that means -1 equal to 0 minus 0 plus 0. So you sub t equals 0 into the function plus c. That means c is -1. And so you have your displacement function. That's nice. This is -1, and the unit should be a mean meter. Okay, and lastly, find the total distance traveled by the car when it comes to rest for the second time. That means the total distance traveled by the car when time equals 5. So you need to find the total distance traveled from 0 t from 0 to 5. Okay, the total distance traveled within this interval. And I'm going to use a calculator to do the thing in one swoop, because what we need is you will probably need to find the position of the car when time is 0. We have that actually, and we need to find what is the position of the car when time is 2, because it's stopped momentarily. It's going to U-turn, reverse. It reverses its direction, and we probably need this. And so I'm going to use a calculator to help me, because calculation is quite complex, I suppose. I enter this function here. Right, and then -7 over 6. And plus 10 over 3, and -1. Alright, so I'm going to use the cal feature of the calculator. I'm going to cal, and I can check this when t is 0 or x is 0 in this case. Okay, you get -1 meter to the left, and I can cal again. And now I want something in 2. So it's 17 over 9. So it's 17 over 9 here, a meter, of course. And let's get the calculator here again. And cal again. And when t is 5, or in this case x is 5, you get 7 over 18. This is 7 over 18. So we can now construct our motion diagram. This is a motion diagram. -1 when at the beginning, or when the observation begins. This is a t equals 0. The car moved to here. T equals to 2. This is a 17 over 9. Okay, so t equals to 2, and it reverses its direction, and back to somewhere here. 7 over 18, and this is when time equals to 5. So we just calculate this. So here it will be, change color to show you. Okay, so here will be a 1 unit or 1 meter, and then here travel 17 over 9. So distance travel would be 1, from -1 to 0, and 0 to 17 over 9 plus 17 over 9, and then plus what else? The reverse direction back here, so means it's from 17 over 9 to 7 over 18. Okay, I think I covered all, and so you do the calculation, you would get 79 over 18 meter. So that is your total distance traveled. I hope you try more questions similar to this, and all the best.